First, I need to make a confession. I like powerful tools, and that has kind of driven me during the last 30 years or something. So I get attracted by technology that looks cool or promises to be cool, and then I explore it until I know it, and that's what I do. So this is how I learned C++ and XSLT and XML and Oracle and Common Lisp and Clojure. And I like this way of learning and spending my time, but that's also not how I am supposed to pick my battles. So I just wanted to mention that there's more ways to pick your battles, like choose a tool. So what is Datomic? I guess that most of you have read through some of the articles describing it, or watching the podcasts or videos or whatever it is. But I want to reiterate what Cognitect, the producer of this commercial database, says about it, because it was something that, well, the marketing that they put out were what also interested us, or what motivated us and me to try to actually use it. So Datomic is the fully transactional, cloud-ready distributed database. That's what Cognitect says. And on the front page they say it is a new kind of database that is bringing data power into the application, that has a sound model of information with time, and that is enabled by architectural advances. So, of course, when doing marketing, you need to describe how your product is different from others, but these are bold claims nevertheless. So let's look at it. So, well, the original motivation for me to try out Datomic was that it is written in Clojure by the people who do Clojure or who develop Clojure. And one thing that Rich Hickey in particular has exposed in Clojure to me is good taste. So Clojure to me is a tasteful language, a tasteful Lisp that has a good mix of things that look good and are easy to use. So that kind of drove me to Datomic 2. And what this means in practice is that Datomic is a database where you can use Clojure as a first-class citizen. So your queries are Clojure, your schema description is Clojure data structures, and the API is first specified in Clojure, and then there are also interfaces for other languages, but they are kind of second class. And I like being first class, so that's why. Also, what you get implicitly is that because Datomic is a Clojure-centric system, you also get to use the Clojure REPL to interact with the database, which is kind of nice, because then you have variables like in Clojure, and you can use standard programs to operate on the structures that Datomic returns you. And, well, coming from C++ and from Perl and from other object-oriented languages, something that I always was looking for was a way to write a program and have easy persistence in the 1980s, 1990s sense, so that I could operate on data structures that outlive the execution of my application. So my basic hope was that Datomic would be a database that makes it easy to work with Clojure data structures and then automatically have them be persisted to disk. That was a hope. Let's look at what enables Datomic's superpowers. So Datomic is immutable. It never overwrites any data that you give it. And the consequence of that is that all history of your data is retained, and that does not only affect the first-class data items that you operate on in your application's data model, but also the indices that Datomic maintains itself. So when you look at the database, it always contains the whole database in every single iteration through time. And this is enabled, of course, by the same techniques that Clojure uses to avoid copies. So instead of copying your whole application entity over time, creating a new version that consists of all the attributes of that entity, it splits up the entity into individual datums, single small items describing the value of one attribute, and then when you make a change, only the changed attributes are written to the database efficiently. The other thing that Datomic's architecture makes kind of unique is the fact that it has reified transactions. So first off, transactions. The claim is, of course, that Datomic is ACID, so it preserves your integrity, and you cannot see half executed operations on the database, and that's the isolation part of ACID. Now, to achieve that, Datomic serializes all writes to the database through the transactor. And the transactor is one process that for your whole database system that does all the changes to the database and executes them. And this transactor can actually run code, user code. So you can, if you, for example, want to change 2 accounts, you need to install a function in the transactor that changes both accounts within this one function. Another part of this is the reified part. So you have these transactions, and Datomic itself writes an entity to the database for each of the transactions that it executes. And this enables time travel. So if you have all states of the database over time, and you also have a way to go from some certain point in time to the state of the database at that point, you can go back to any point in time in the database and retrieve data at that point back in time. And well, this gives you all kinds of opportunity, and the idea would be, okay, I don't have to do anything, but if I want to find out how my data looked like a year ago, I can just go into the database and look at it like it was a year ago. Now, to really make this work, there is an inherent model of entities in Datomic. So transactions are entities, users, things are entities, and there is a schema that governs how Datomic treats these entities. For example, you can have an entity that points to many other entities, or you can have one-on-one relationships, and these relationships are automatically maintained by Datomic. And this schema, well, it is a schema, and when looking at database systems, you sometimes find databases that have no schema, and you have database systems that have schemas. So our idea as application developers of a schema is that you can describe the shape of your data, and that the database will automatically maintain that shape. So that would be my idea of schema. And lastly, one thing that Datomic has, and that is kind of unique, is data lock. So many database systems do not have many new database systems do not have a declarative query language. Datomic has something that is called data lock, that is very old, a relative to Prolog, and it has the idea of unification variables and joins. So you can join over your table. You only have one table, but you can join over that and have many different joins unified through unification variables. Well, I just need to whirl through this, but it's from the perspective of application development, having a declarative query language is certainly better than having to compose your queries into function calls and then collecting your data yourself. And data lock actually works well for us. The other thing that it has is it has a way to specify how the shape of the data that you retrieve looks like. So instead of, well, in an SQL query, you would always have rows, and then you would have multiple queries to retrieve multiple rows and compose that into a nested data structure. In datalog plus pull specifications, you can specify a nested data structure and then use datalog and pull specifications to create a nested structure that exactly contains what you want to retrieve. So there's no select star, there's no pulling of attributes that you don't want if you don't want that. So here we have ICN frequency status blah 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 blah. We list all that and retrieve exactly that part of our data model. So all of this sounds great, and now we as a company, we do insurance data processing, and our main business is dealing with legacy systems that send us files and that we somehow need to ingest into databases, or we need to format files in certain form and send them to other systems, and that's kind of the basic business that we do. So much of it is just reformatting data, but sometimes we also have complicated conversions from one data model to another, where we need the database to help us keep track of what we send to one system and what we receive from another. When we initially started, we used Postgres and had because the legacy system that we were interfacing to had that as the basic database. But Postgres is restricted in its data model because it's an SQL database, and we wanted to have something that is more flexible so that we could easily work with hierarchical data or have complex interaction between objects and stuff like that. So we tried Datomic. And when we initially looked at Datomic, we found the interface to be rather basic. So instead of having a description of your data shape, you had to write a schema in a very low-level form with lots of keywords, with lots of namespaced keywords, and it was very hard to see the actual schema through all that boilerplate that you had to write. And when we started the first application, it was a very simple one, file transfer monitor. It's something very simple. There's a system, it has files, and we want to pull files off it and need to keep track of what we pulled and what we didn't pull. So we thought, okay, let's try something simple. We wouldn't even need a database, but let's try Datomic. And in the process, we recognized that Datomic required us to follow the things, like the namespace keyword symbols and all that kind of stuff, very closely in our application code. So it's not at all a database that persists your Clojure data structure. It's a database that uses Clojure data structures, and you have to architect your applications around that. But we used it for learning, and it worked well so far, but then we decided the complexity of Datomic is not worth it and replace it by simple files. So the next thing that we did was a data model matcher, where we have one system and another system. They talk about the same facts but have different data models, and we need to match the two. So we need to find out what one system does and incrementally update the other data model. And this creates basically edits to trees, edit commands. And one of the problems is that Datomic doesn't have a story for blobs. So we chose a hybrid approach to back Datomic on Postgres and store XML blobs in Postgres too. And we deployed that in June 2015, so a year ago, basically. And now we have 150 million datums in that database and 20 million entities. And that's about 100 gigabytes of data, which is kind of, I would say, large to us. And the one thing that we really liked was the fact that we at some point had to visualize parts of that complicated matching data back in time. So it was not clear what the system was doing, and it was a big revelation that we could just write a visualization for that and then go back in time and see, this changed like this, and we didn't have to actually plan for this in the data model that we initially implemented, but we could just use a simple query to a simple parameter to the query to change the point in time where we are looking. But this comes at a cost, and the cost is that when we deal with data that is not clean all the time, we make mistakes, or we import data that contains crap. And then the question is, how would we get rid of that? And if we couple our application model of time and when did something happen to the system model of time that the database provides, then we basically cannot make any edits back in time, even though we need to. So if there is a bug in our program that prevents us from doing the right thing, what we need to do is we need to read the complete database once more and edit at the point in time so that we can get rid of the data that we don't want. The other thing that we learned is that the Datomic schema is not really meant to support applications. It is meant to support Datomic's internal operations. So for example, if you specify that an entity has one instance of a certain attribute and then assert that attribute again, Datomic looks at its schema, knows that it's a 1, the cardinality of that attribute is 1, and automatically retracts the other fact so that only one of these attributes exists at the end of the transaction. But this is really just supporting the Datomic data model, and as an application you often want to have constraints like a string only may have certain values, or you may want to restrict the internal references to point to certain entities of certain types, stuff like that. Datomic doesn't have all that, and we have explored prismatic schema to do that. We have also thought about Clojure spec to do this, but in essence what this means is Datomic doesn't have any meaningful application level schema. The other thing that we ran into is that the size restrictions of Datomic actually matter. So Cognitect is really, they say this is a database, and you don't need to really worry about the size problems, but they are real, and the size problems are in various dimensions. So for one, your transactions need to be short enough so that you do not make other processes wait for too long. You cannot have attribute values that are greater than a few kilobytes. You cannot have more than a few billion triples, or datums, what they call them. So these are real restrictions, and we have been hit by all of them in practice and had to engineer around the restrictions of that system, which is, we don't like that. The biggest issue that we have with Datomic is long transactions. So because you need to execute the transaction from beginning to the end in the transactor, and everybody else is waiting, who wants to write needs to wait until your transaction finishes, you cannot ever have something that really takes a long time. And really takes a long time, that means 3 seconds, 4, that's too long. And for us, this is a problem because we are dealing with large files, and we often have operations that affect 1 million, 2 million entities, so it doesn't work for us. And also, this is a real problem if you have to import legacy data, for example, or do data imports of any sizable magnitude. The other thing that we now experience is that the lack of garbage collection is a problem. So we have 100 gigabytes of data, and of that 100 gigabytes, maybe 10 gigabytes or maybe even only 5 gigabytes are really meaningful, and the rest is just crap from the past. Even though it is not a huge amount of data, when we want to have a copy of the database, we automatically have like 100 gigabytes, and if we are one more year in, we have 200 gigabytes, so it's really getting unwieldy. And finally, and this is really a reflection on the time travel thing, migrations are a huge problem with Datomic because in a normal monotemporal only current database system, what you can do is you can change your schema and then you can change the data so that it conforms to the new schema, and that's what we all do with migrations, and it works kind of. It's a problem already, but with universal history and Datomic, what you also have to consider is that you actually want to be able to roll back in time and look at the data at some place in time in the past. So either you can forget all that and not be able to roll back, or you have to roll forward to all history to make sure that the data back in time looks the way that your current code expects it. And this is really a big thing to us. So I must say, we are at the end. And we need to reconsider our choice of database. I wouldn't say that it's really just because Datomic is bad. One could also say that we didn't really understand the problem domain, and we have learned a lot by using Datomic. But in general, I would say that the claims that Datomic allows time travel and gives applications a way to go back and really use things back in time, that really holds true only if you never change your program. If you write a program and run it for years and never have to maintain it, then you also don't have to maintain your data. If you have to cope with changes and with errors and with data that doesn't really look like you expected, the time travel is really just snake oil. That's all I have.
Hi, I got a question, right? It seems that this database is only useful for Clojure, it's full power, right? But it got interesting concepts like it provides asset capabilities, right? And on the other side, it's kind of new. So do you know other projects that base on these concepts, right? Immutability and provide asset transactions that can be useful in other languages?
Yes, in fact, what we do now is we migrate to MarkLogic, which is another commercial database, and it's even more expensive than Datomic is. And that has multi-version concurrency control, which is a standard implementation feature for doing concurrency control. And there you can just control how large you want your history to be. By setting the merge timestamp. So it's something very, very easy, and MVCC as a database technique is also not something that Datomic has invented. So so yes, there's other projects, but what we really learned is that tying the technical point in time to the application point in time is not the right thing to do, because if you need to be able to roll back in time, then you need to also model for that on the application level. Otherwise, you get into these problems that your database dictates how you need to treat your time. So, for example, with Datomic, I mean, it's really a mess, and we have now spent 4 weeks just engineering a migration that allows us to read the database from back to front to create a new data model. And now we are at the point where we ask ourselves, do we want to put this into Datomic? No, we put it into something where we have the data model and where we can put into the in all our blobs, and where we can have long transactions. So we now know that, but that's kind of the result of using Datomic in the first place. So I'm not complaining, it's just how we learned.
Experience, what is actually use case you will use Datomic with what you know? You know, because use cases are...
Yeah, I mean, if you are one person, it's a good use case, because the ability to interact with Datomic from the Clojure REPL is nice. So that's a nice thing, and if your data model is not influenced by external data a lot, but if you rather are writing an application and you are willing to to adapt to Datomic's way of dealing with entities, it's nice. And also, some of the problems that we have identified on the superficial source code level, dealing with namespace keywords all the time and not having a schema, that's something that Clojure is going to address in 1.9. So in 1.9, you will have Clojure spec as the standard way of conforming data to some declarative description. That's great, and that works. That probably works very well with Datomic, although we didn't try. And the other thing is that they are coming up with a literal syntax for maps that allows you to not repeat the namespace all the time. And this is really kind of the thing that makes source code unreadable, is you have a lot of repetition of the namespace all the time. So I wouldn't recommend against using it, but it's probably better if you don't have to deal with data that you don't generate yourself.
All right. Thank you very much, Hans.